So we are starting our unit on radical functions. We're finally moving on from rationals. We're done with rationals, and now we're doing radicals. After radicals, we're going to do logarithms and exponential functions, and then conics, and then we're done. Done for the year. So just technically 3 more types of technically 4 more types of equations, and then that's it. Okay. What do you think a radical function is? Oh my gosh, it has a radical in it. Yeah. Now, this could be a square root. It could be a cube root. It could be a root to the 4th power, 5th, 6th, 7th. Anything that has a radical in it is in this unit. But today, our transformations day, we're just going to go over square root and cube root. Now, the first thing we're going to do is graph these. How do you think we can graph them?
A calculator?
Nope, without a calculator. We're doing it without a calculator.
Did you just put like 1 in for x?
Yes. Just substitute values in for x and see what the y is at that point. So, when x is 1, we'll start with 0, always 0. When x is 0, what is y? Right, what's the square root of x? 0. 0. So we have a point, our first perfect point at 0, 0. Then let's go up to 1. When x is 1, what is y? What's the square root of 1? 1. So we have another perfect point at 1, 1. Now, do you think it's easy to square root 2? No, right? It's going to give you some decimal answer. So let's go up to a number that will give us a whole number answer. 4. What's the square root of 4? 2. And then what's the next perfect squared? Is it on this graph? 9. It's off the graph. So these 3 perfect points work for us.
What about negatives?
So let's talk about that. Let's take x as negative 1. What is the square root of negative 1? It's plus or minus I. Can we graph I? No, right? It's an imaginary. It does not really, in the real world, and certainly a graph is a depiction of real, imaginary does not exist. So no, we cannot graph imaginary. What about when y is negative? So let's take y to be negative 1. Does anything square rooted equal negative 1? No. No, it does not. Okay? So, is this the finished product of our graph? It is. We're done. That's all we can graph. That's it. Done.
So for things like that, you'd never have negative.
Right. Okay. So, and actually, should I talk more about this? Okay. What does this look like, kind of? What does it look like? What other graph? Half of a quadratic. And in fact, this this square root is a depiction of the inverse of a quadratic. So square root is the inverse of a quadratic. It's like we took a quadratic and inversed it, creating this. Now, why did it not continue and do the whole thing? We can't have imaginary, right? So later on in the unit, when they ask us, they're going to give us a parabola, they're going to give us a quadratic, and they're going to say, find the inverse of this function, and it will give the entire thing. We're going to have to restrict the range here. Restrict the domain to give us this graph. But again, that's later on in the unit. Don't worry about it too much now. Okay, so let's graph the cube root. Where should I start?
0.
Yeah, so what is the cube root of 0? 0. So again, we start off at 0, 0. What about the cube root of 1? Remember, so square root, if I'm square rooting something, right, it's asking what times itself would be that number inside of the square root. So the square root of 4, we know 2 times 2 is 4, so the square root of 4 is 2, right? Here, if I am cube rooting 1, what times itself 3 times is 1? Right, 1 times 1 times 1 gives us 1. So the cube root of 1 is 1. What's the next perfect cube? 8, right? 2 times 2 times 2 is 8. So when your x value is 8, what is the cube root of 8? 2. So when the x value is 8, our y value is 2. Now, can you cube root negative numbers?
Yes.
Yes, you can, right? You ask yourself, okay, let's try negative 1. What times itself 3 times is negative 1? Right. So we're trying to cube root negative 1. What times itself times itself times itself is negative 1? Negative 1, right? Negative 1 times negative 1 times negative 1 gives us negative 1. Yeah. So the cube root of negative 1 is negative 1. What about what's the cube root of negative 8? Negative 2, right? Negative 2 times negative 2 times negative 2 is negative 8. And that's our graph. What does that remind you of?
The other one.
What other ones?
The ones that they're supposed to go like that.
Yeah, what one goes like that?
Polynomial.
It is a polynomial. What specific polynomial is it?
Rational.
Cubic function. Yes. It reminds us of a sideways cubic function. And actually, why does this make sense? What was this? What did this remind us of? Quadratic, which this is the inverse of a quadratic. What did this remind us of? Cubic, which this is the inverse of a cubic. Oh. Oh, okay. And we'll learn more. We'll go more into depth about inverses. They'll make more sense to you later on.
So, Ms.
Yes.
Sandra,
Yes.
could you, instead of plugging in an x value, plug in a y value?
You could. In this case, it'd be harder. No, it wouldn't. You do 2 times 2 times 2. It doesn't matter. I just always plug in x values because x is the independent variable, right? So I like to plug in x values. You could plug in y's, sure. All right.
Seems like y might be a little yeah.
Yeah, maybe. All right. So now let's talk about the domain and range of these parent functions. What is set notation? Which one is that?
The one where you do the squiggle bracket?
Squiggle bracket. Yes, it's set builder. It's the big long thing you build. So we start off with squiggle bracket. Then what do we do?
X, E,
Is in all real numbers, is an element of all real numbers, such that.
X,
Now what's our lowest on this graph? What's our lowest x value?
negative
0, right? My lowest, I'm going lower, I stop at 0. Am I touching 0?
yes.
Yes, I am. I'm touching 0. And what's my max value? Infinity. So what can I write here? There's two ways I can write it. One is just less writing. Nope, that you're mixing set and interval notation.
Oh no, I'm
X is greater than or equal to 0. You also could have written this, but that's more writing, right? You don't need that is less than infinity. Right? X is always bigger than 0. Okay, how would this look in interval notation? Yes, it's the brackets and parentheses. What is our least value? Is it going to be a parenthesis or bracket? Bracket. 2 infinity. Good. What is our lowest y value? 0. And what's our max y value? Infinity. Right? It keeps going up. It keeps going up. So it's the exact same thing as the range. I mean the domain.
Is this always going to be the range?
No. So if it is translated, say, 2 to the left and 3 up, my domain would be 2 to infinity, and my range would be 3 to infinity. So no, this will not always remain the same. Good question. Okay. And now, well, what's the x-intercept? 0, 0, and the y-intercept is? And does it have a min or max value? It does have a minimum value at what y value do you have this point? 0. When y equals 0, that is our min value. And then here, why are some values excluded from the domain? So what values did we not do for the domain? Which ones? A whole set of numbers that we didn't include. Negatives, right? Why did we not include the negatives? Right. If we input negative values for the x's, we will receive imaginary numbers for the y's, which cannot happen. So here, why are some values excluded from the domain? Whoops. Because negative numbers as x values will produce imaginary y values. And why are their values excluded from the range? Let's go back up to the domain and set notation for a cube root. What is the domain? What is the least value for a cube root? Negative infinity. And what's the max value? Positive infinity. So guess what? It's all real numbers. And for a cube root, the domain and range will always be, excuse me, all real numbers. Always. Just like a cubic, it was all real numbers. And what was our x-intercept? 0, 0. And our y-intercept? And did it have a max and min? No, none. Why does this make sense for a cube root function but not a square root?
What are we asking?
Why does this make sense for a cube root function but not a square root function? So why can we include the negatives is the question.
Oh, because the negative and the negative equals a positive.
Ah, yes, because you can cube root a negative. Yes? And that's all we'll do before lunch.